The first video would be a review on max likelihood. So we're gonna say an example. So the problem is from one of the discussion. I believe this is discussion 23. And this is for problem 4. Problem 4 says, suppose x is a exponential random variable with a known parameter c. So we know that exponential random variables format is c x to the negative bx. It's ce to the negative cx. And we are doing the maximum likelihood of 5 measurement. We measure it 5 times and get a result of 25, 30, 33, 27, and 31. So we want to use maximum likelihood estimate to estimate the C in this method. So remember, if we use the logarithm or want to estimate C given the data x1, x2, x3, x4, and x5, the calculating the logarithm, the maximum likelihood is basically we look at the distribution of each measurement. In this case, it will be C, E, negative C, X. This X, we write it as X hat because this is an estimate. Times C, E, negative C, X2 up to C, E, negative C, X5. The reason why we do this because we know that these 5 measurements are disjoint, and we have 5 measurements. If we only have 1 measurement, we use the exponential hierarchy, but we have 5 disjoint measurements, so we can write this as the probability of x1 times probability of x2 times up to x5. So remember, the objective of maximum likelihood is to find the minimum. So we have 2 ways to find the minimum. You can either do derivative, or for some of the function, adding I would say composite logarithm first and then do derivative to find the minimum. In this case, because the function consists of e to the some power, and it is more convenient if we can use logarithm estimation. So we say that the log of this function is equal to the log of c to the fifth e to the negative c x1 plus x5, and this would be 5 log c minus c to x1 plus up to x5. Yeah, so basically we use logarithm to simplify this function, and then we take derivative with respect to c to find set it to 0 to find the minimum. So we take derivative on this function, and we end up getting 5 over c minus x1 plus x2 plus x3 plus x4 plus x5 set up this to 0 to find the critical value. So in this case, say we equal to 5 over x1 plus x2 plus x5. And we know that we are given x1, x2, x3, x4, x5. They're given in the question of 25 plus 30 plus 33 plus 27 plus 31. So this gives us a result of 0.03425, which is the maximum likelihood estimate for this specific distribution. So for this type of problem, you need to first identify the distribution. And then you need to check if it is lots of observation or just one. And then if it is like one observation, you can just directly use the distribution. If it is lots of measurement, make sure they are disjoint. But like for in the scope of this class, for multiple measurements, they should be all disjoint. So you don't need to worry about that. But like maybe mention this sentence and then like set up the equation. Set up the equation. So the equation in this case, it will be this equation. And then you need to, that's all set up, and then you need to like do the algebra. You can either do it by applying derivatives directly, or you can apply log first and then do derivatives. And finally, you will compute the critical value and the minimum. But the maximum value. And the maximum value. So theoretically, you should check using second derivative, or I wouldn't put this theoretically. You should check using the second derivative, or plug in to the function to say that they are actually the maximum of the function. So that's the review for maximum likelihood.